Welcome to our discussion on incorporating references to external knowledge bases in prompts. We'll explore how connecting language models with these sources enhances artificial intelligence capabilities for more accurate and reliable outputs. Enhancing AI with external knowledge addresses limitations of large language models. It improves response accuracy and relevance with verified facts, provides up-to-date information beyond training cutoffs, and creates more trustworthy systems with verifiable answers. This integration also expands AI capabilities into specialized domains. Knowledge integration methods enhance AI by using retrieval augmented generation, which fetches relevant documents before generating responses. Knowledge prompting involves injecting factual statements to guide accuracy. Application programming interface and database references allow models to access real-time data, ensuring up-to-date and precise responses. A knowledge base is a structured repository of information. It includes databases, application programming interfaces, vector stores, and document collections. Examples range from public sources like Wikipedia and Wikidata to private company documentation and proprietary databases. Internal model knowledge is encoded in model weights during training, fixed at the cutoff date, and may lead to outdated information or hallucinations. External knowledge sources, retrieved at runtime, provide up-to-date, verifiable information, including proprietary data enabling specialized expertise. AI models often lack knowledge of events post-training, specialized expertise, proprietary data, rapidly changing information, and personalized contexts. By comparing model outputs with trusted sources, you can pinpoint where external knowledge is most beneficial. To evaluate an AI model's native knowledge, start by asking probing questions to establish a baseline. Assess the response quality for accuracy and depth. Identify where the model's knowledge ends, and create a plan to enhance it with external sources. Use external references for recent events beyond the model's training date, real-time data like current prices or weather, and compliance requirements needing verifiable sources for regulatory adherence. For real-time data, use APIs like weather services or stock market APIs. Structured records are best sourced from databases such as product catalogs. For recent events, news APIs like Reuters are recommended. Domain expertise requires specialized documents, including academic papers. Company information should be drawn from internal knowledge bases such as employee handbooks. Retrieval augmented generation, RAG, combines traditional search with generative AI. It searches external sources, retrieves relevant documents, and incorporates this information into the context window. RAG generates responses using both model knowledge and retrieved data. Introduced by Facebook AI Research in 2020, it is now a standard for knowledge-grounded AI systems. RAG begins with a user query seeking factual information. The system processes this query into search terms or vector embeddings. It retrieves relevant documents from a knowledge base, augmenting the context. Finally, a language model generates a response using both the retrieved data and its own knowledge. RAG approaches enhance accuracy by grounding responses in verified sources, reducing errors. They provide up-to-date information by retrieving current data, overcoming training limitations. RAG accesses specialized knowledge, filling gaps in general training data. Additionally, it offers transparency and trust by citing sources, clarifying the AI's reasoning process. Knowledge prompting involves prompting a language model to generate factual statements, which are then used in the main task. Unlike retrieval augmented generation, it relies on the model's internal knowledge, eliminating the need for external retrieval. This technique can enhance responses and integrates well with retrieval augmented generation for hybrid approaches. In two-stage knowledge prompting, a user poses a factual question. The model generates relevant facts, which are filtered for relevance. These selected facts are then injected into the prompt context, enabling the model to produce an enhanced response. Penguins are flightless birds with flipper-like appendages evolved from wings. These flippers, containing the same bones as bird wings, are specialized for swimming, highlighting their evolutionary history. In response to whether penguins have wings, the answer is yes, but they are adapted for aquatic life rather than flight. Direct in-context references enhance accuracy by using specific sources. URL citations allow precise content referencing, like the CDC's report on vaccination rates increasing by 12% in 2023. Quote blocks provide authoritative insights, such as sales data showing growth from 1.2 million in 2021 to 1.8 million in 2023. API integration involves function calling, tool use, and plugin systems. Common integrations include weather services, financial data, search engines, and e-commerce systems. These approaches enable models to access real-time data efficiently. Knowledge-enhanced systems excel by integrating multiple sources, prioritizing relevance, reliability, and recency. They utilize structured databases like SQL for precise data, unstructured documents such as PDFs and web pages for narrative content, API services for real-time data, and user context for personalized experiences. Integrating external knowledge presents challenges like latency issues, which can delay user experiences if not optimized. Information conflicts arise when model knowledge contradicts retrieved data, requiring resolution through confidence scoring. Additionally, context window limits necessitate summarizing or prioritizing large data volumes to fit within model constraints. To implement knowledge integration, start by assessing your goals and knowledge gaps. Select reliable sources, design an integration architecture, and develop prompt templates. Finally, test and refine the system to enhance accuracy and performance. In prompt engineering, ensure structure and clarity by being explicit about required knowledge and using consistent templates. Manage context by prioritizing relevant information, summarizing large documents, and including source metadata. For example, use a template that separates context from tasks, ensuring transparency and precision in responses. Prioritize high-confidence facts supported by multiple reliable sources in responses. Medium confidence information with some evidence but potential inconsistencies should include caveats. Exclude or mark low confidence facts which have limited or questionable sources as uncertain. A financial advisory chatbot faced challenges in delivering current market data and personalized recommendations. By implementing retrieval augmented generation, it accessed real-time stock prices and market news, connected to a proprietary client database, and incorporated financial analysis principles. This improved accuracy from 63% to 96% and boosted client satisfaction by 45%. Currently, most systems rely on manual integration, needing explicit engineering to connect knowledge sources. Emerging models are advancing towards self-retrieval, autonomously identifying knowledge gaps. The future envisions knowledge ecosystems, where integrated networks of specialized models and sources collaborate seamlessly. Integrating external knowledge significantly enhances AI accuracy and relevance. Various methods, from simple references to complex retrieval augmented generation systems, are available. Successful implementation hinges on careful source selection and prompt engineering. The future of AI relies on seamless knowledge integration. Identify gaps, experiment with techniques, and measure improvements in accuracy and satisfaction.